So as you can see, I've been using mean squared error for the loss function, though I've always wanted to try out different loss function well known within the reinforcement learning called Hoover or Hover, and this is its gradient. And normally you'd set the delta to 1, and this is how it works. So first of all, we compute the error or difference between prediction and the truth, and we take the absolute value of it, and if it's less than or equal to 1, we square the error and multiply by 1 over 2, which kind of which kind of behaves like mean squared error, because we also within the MSE we also square the error, except we multiply by 1 over 2. So if the error is less than or equal to 1, those are same, I guess. I somewhat same, similar. But if the error is greater than 1, we subtract 1 over 2. So it kind of behaves like mean absolute error loss function, except we subtract 1 over 2. And the difference the up to this point, the difference between Huber and MSE is that no matter how big the error is with MSE, you square them. But if the error is big, so the reason people choose 1, or I did some research, but people sometimes you use 1.35 for the delta is this, because this acts as a threshold which determines whether the error is big or not. So if people use delta as 1 or 1.35, which means if the error is bigger than those values, you can say that error is big. And with Hoover, if the error is greater than 1, you won't square them, but with MSE, you will square them. But this is just um, those differences. This difference doesn't really matter eh, because it would just contribute to this value, and I don't re- I just use this value for logging, and what really matter is how big error gets within the gradients, because those gets back propagated during the back propagation. So during the gradients with Hoover, if it's less than or equal to 1, we multiply by 1 over n, and n means number of elements. But with reinforcement learning, n means number of batch size. So if the batch size was 1, you just get error. And so with mean squared, the gradients for mean squared error, it works kind of like how Hoover gradients works, because you multiply by 2 over n. This is n again. So if the error is less than or equal to 1, Hoover grad and MSE grad work. I mean, yeah, they're kind of identical. But if the error is greater than 1, it gets clipped to 1. But with mean squared grad, you multiply by 2. But but if let's imagine if the error was quite quite big, like 10. With Hoover, it gets clipped to 1. But with mean squared grad, you multiply by 2, so it would be 20. And 20 versus 1, I mean, the gradients for 20 is really huge. You might you might experience gradient exploding, and I think the neural networks would have hard time converging to global minimum, or eh, like, yeah, big gradients are really bad. And if it gets to clip to 1, eh, it really saves neural network from um, gradient exploding. So the biggest difference between using Hoover or MSE is the gradients gets clipped or not. And for my case, actually, the errors for my setup rarely gets bigger than 1. It's way smaller than 1. So yeah, I figured out I don't really need to use this Hoover. But so sometimes the error these error gets big with using reinforcement learning due to these reasons, like unusual rewards and bad initial Q estimates. Unlike supervised or unsupervised learning, with with these paradigms, once the loss gets converged, it it's pretty rare for the loss to be to get bigger again. But with reinforcement learning, the loss is pretty random because of these factors. Sometimes the loss gets big even though you have trained for, I don't know, 1 million steps already. So yeah, if the if your errors are not big, like not bigger than 1, I think you can stick. I think you could stick with MSC like I do. Like, yeah, I yeah, I've decided to stick with MSC. So yeah, that's it. And thanks.